There are certain assumptions when you run the t-test.
Let's take a look at what the assumptions are. The first one is that the dependent variable y is normally distributed in the population. Now, your sample may not be totally normally distributed, but the assumption is that in the population, the dependent variable is normally distributed.
Simple random sampling has been used to draw the sample from the population.
The level of measurement of the dependent variable, y, is continuous, that is, interval or ratio.
Homogeneity of variance means that the two samples that you've drawn from the population will have the same variance. This assumption is necessary because the variability of the population is estimated by combining the data from the two samples regarding variance.
The last assumption is independence of observation. This assumption means that observations within each cell are independent of one another. You've seen we've actually already violated that assumption when we did the dependent t-test. We'll do more about that independence assumption in later chapters as well.
As it turns out, the t-test is actually quite robust to these assumptions.
Robustness refers to the ability to not meet the assumption, yet the test still be accurate. Let's use an example from SPSS. Here are the results of an SPSS study where we had 100 females and 100 males. We looked at their push-up scores. In the top frame, we have their descriptive statistics, and in the bottom frame, we have their results from their independent samples t-tests. So let's take a look at these results.
Notice that the mean for the females is 14.37 and for the males is 20.04. Now the question is that difference statistically significant?
Let's take a look at one of the assumptions, that of homogeneity of variance. Levine's test, indicated here, is a test of whether or not variances are equivalent across males and females. And you'll notice that the significance, or p-value, indicates that they are not the same. If you go back up and look at the standard deviations for the females and the males, you'll notice that the standard deviation for the females is about 8, therefore the variance is about 64. That for the males is nearly 12, so the variance there would be 144. Therefore, we have to assume that the variances are not equal, so we don't meet that assumption. What impact does that have on the t-test results? You'll notice that there are two different lines presented in the push-up output. The first was when variances were assumed to be equal, and the second line is when the variances are not assumed to be equal. Essentially what happens, there are slight adjustments which make the test less likely to find a difference if the variances aren't equal. Notice that on both lines the t-ratios are exactly the same. What really changes is the degrees of freedom. Notice whenever you have equal variances not assumed, the degrees of freedom are reduced. Essentially that reduces what's known as the power of the test. But importantly in this example, they both, whether variances were assumed to be equal or not assumed to be equal, they both result in rejecting the null hypothesis. SPSS provides you with a test of the equality of variances anytime you do a t-test.